getting started. So we're going to talk about Azure Route Server and bit of Azure networking, as well as the routing in general, as well as some scenarios which Azure Route Server, uncovers or helps provide. And obviously, we'll have Q&A. If anybody has any scenario wants to discuss, we can do it in the end of the session, or feel free to ask your questions during the session as well. So when we talk about Azure network topology, and specifically when we are talking about the Azure cloud adoption framework, and when we look at the Azure landing zone, especially for the network topology, we have got two patterns. The first pattern is the managed network, which is achieved using virtual WAN. So you get your virtual WAN and connect all the virtual networks together. So it's more like a managed, service from Microsoft, which is pretty much like buying a house off the shelf. So you purchase a house, it comes with the features, and you cannot modify much of the features. Versus another option is do it yourself, which is the traditional hub and spoke. Now, in the hub and spoke, you actually are building your house. Means you define what virtual network you want to create, how many peers you want to establish, as well as what network virtual appliances you want to deploy. So that's the traditional hub and spoke. Now, Azure Route Server fits well in do-it-yourself, which is traditional hub and spoke networking. Now, do-it-yourself networking, hub and spoke, it's good for customers who want to have granular control over their network, and they're also looking for deploying it in a one specific Azure region versus connecting multiple regions. And if you want multiple regions, you would better use Azure vWAN. Now, hub and spoke is also good for customers who are trying to deploy multiple or different third-party network appliances like, FortiGate, firewalls, or maybe, Cisco NVAs and things like that. And again, this is good for customers who have got low number of remote branches, which is close to 30, because that's the limitation of the native VPN gateway in hub and spoke. Now, before I talk about Azure Route Server, I want to just touch base, the basics of Azure network routing. Now, when we talk about Azure network routing, or in general, when we deploy the virtual network in Azure, what it gives us is it gives us the capability to deploy multiple subnets. So the virtual network is kind of extension of your network in Azure, and it also allows you to carve out this network with multiple subnets. And by default, these subnets can talk to each other. So that's kind of a default system route. And what it gives you is basically if you have one VM sitting in one subnet, and if it needs to talk to another VM in another subnet, that would just talk to each other. That's the default routing behavior. And that's called as system routes. Now, with the help of system routes, if you peer your virtual network with another network, these two networks can talk to each other. And this is kind of a default way of routing. And this is what Microsoft provides to you. Now, if you're not looking for a default routing, and if you want to route a traffic to a specific network virtual appliance or a firewall or a specific destination, or you want to restrict it, that's where you would look for overriding these default routes using the user-defined route. So user-defined routes, it allows you to manipulate the existing system routes. So let's say by default, your virtual machine can communicate to internet and it's allowed. And if you want to restrict and you want all the traffic to pass through using some third-party network virtual appliance or Azure firewall, you will override these routes. And with the help of Azure route tables, you will forward all this traffic to a virtual appliance. So you will deploy a virtual appliance, you will configure Azure route tables, and with Azure route tables, you will override the system routes and will say for any traffic which is destined for internet, like 0.0.0.0/0 should go to this specific IP address. So if you look at the routing in general, so this is how the the routing looks like. So this is the routing information, which is called as effective route information from a VM, which is deployed in Azure. Now, if you look at it here in the upper section, we have got routes, which are called as default routes. So any traffic within the virtual network is all active, means we don't need to go anywhere. We can communicate together. Now, this VM also has got, or I would say this VM is deployed in a VNet, which also is paired with another VNet. And that's where it is getting the peering information, which means these routes are coming from network peering, and it shows the next hop is my peered network, and this is my network which I'm peered with. So this is my default network which I'm part of, and this is my 1.0 is my peer network where I can communicate. And then we have got a whole bunch of routes we are receiving using BGP, and they are like a virtual network gateway. So if you deploy Express route or site-to-site VPN, by default, these routes gets injected in the VNet, in the hub, as well as if the hub and spoke topology is implemented, they also get injected in the spoke as well. So by default, a VM sitting in this virtual network can communicate to the peer network, and it can also communicate to the network, be it Express route or be it site-to-site VPN. So this is kind of a default behavior. Now, if you would see here in the bottom, there is a route which is showing as invalid because that was a default route which was created by Microsoft. So going to internet was a direct option, whereas I have overridden it using my user-defined route, and that is just sending this traffic to this IP address, which is 192.168.1.5. So we can manipulate these routes using the route table, which is also called as user-defined route. So this is how the routing looks like in an Azure virtual network or in a VM when we look at the effective route. And I'll show you in a VM properties as well that how these routes look like. Now, in terms of the priorities of these routes, we have got system routes, which have got the lowest priority, and these routes are injected in the VNet by the platform. So this is kind of managed by platform. We can't change it. It is what it is. Then the second priority comes is the BGP route. And these BGP routes are actually learned when you have virtual network gateways. And if you've got Express route, you learn these routes from your on-premises. So if you've got the on-premises router, and if you're using BGP, you can propagate these routes to the virtual network gateway, and virtual network gateway further inject these routes in all the virtual network. Now, if you need to override any of these routes, we can always use the user-defined route by creating the route table. So that's how the routing works in Azure Virtual Network. Now let's talk about Azure Route Server and what it is. So Azure Route Server is a new service introduced by Microsoft, which is currently in preview. It provides the BGP endpoint for network virtual appliances. So if you've got the network virtual appliance, now the network virtual appliance can actually inject the route in a virtual network. So by default, we had to create the route table to tell the route for an internet for a specific network by using the route table to the virtual network and the subnet. Now we can do it with the help of route table, where the NVS can inject their route directly to the virtual network. It also provides the dynamic routing between NVS and virtual network. It simplifies the NVA deployment, especially in a case where a customer has got NVAs and they have got multiple virtual networks, which are peered as well. Now you need to configure a lot of route tables to route the traffic through the NVA, whereas now this can all be done without the need of the route table. It also supports any network virtual appliance which supports BGP. So by default, or I would say as of now, Azure Firewall doesn't support BGP, but any network virtual appliance, be it Cisco, be it Palo Alto, FortiGate, those network virtual appliance can be utilize. Now, the another benefit of Azure Route Server is it also helps you, exchange the routes between Express Route and a site-to-site VPN, which means it allows you to achieve a scenario where you've got a branch office and you've got main office. And if a branch office has to connect any service in main office, they can come through the VPN to Azure, and from there the routes will be exchanged, and they can connect to the on-premises. So without a branch office and main office having a VPN, they can also transit this connectivity using Azure as well. So without the route server, that's not possible. But with route server, that option is also possible. Now, Azure Route Server, it's a fully managed service. So it's kind of managed by Microsoft. And when you configure the Azure Route Server, what it does, it basically deploys to route server service in Azure. And you won't be able to access these services. The only thing what you see is the configuration blade and the IP address of the route server. Now, this is highly available and fully redundant, which means if you deploy it in the region which supports the availability zone, the route server service will deploy it in like AZ1 and AZ2 to provide the high, redundancy. Now, route server, it supports multiple NVAs, which means you can deploy multiple NVAs, and it supports the mode like active-active as well as active-passive. So active-passive is supported using the AS path prepending, which means you would need to prioritize one route in NVAs than the other. And there is another option which is active-active, which support ECMP, which is equal cost multi-pathing, which means both the NVAs are highly available and the traffic can route using any NVA as well. So these are the two scenarios which can also be achieved using the route server. Now, there are some requirements for deploying the Azure Route Server. So it uses the ASN, the AS number, BGP, which is fixed from Microsoft, which is 65515. So if you are using any NBA or if you are using a site-to-site VPN, which is currently using 65515 AS number, that cannot be used because it is used by Microsoft. And NV cannot use the range reserved by Azure or IANA, which means Azure has reserved the range from 65515 to 65520. That AS number cannot be used, but you can use any other AS number. And if the route server is deployed in a network, which is currently in use, and if you've got VMs deployed, the VMs may lose the connectivity for some time to the on-premises. And route server requires a subnet with the name route server subnet with /27 subnet mask. So that's kind of a requirement for route server. Now with this, I will jump onto a demo and I'll show you how do we configure route server and what's kind of a requirement for route server. So this is my demo environment. To simulate this demo, what I've done is I kind of deployed a hub and spoke architecture. So I've got a VM sitting here, and I've got a spoke here as well. And so basically, they are connected with Express Route as well as a site-to-site VPN gateway. So this scenario is a bit kind of simulated hub and spoke in Azure, and it's connected with Express Route to a Google Cloud. So there is a kind of on-premises which is mimicking by deploying the VMs in Google Cloud, and there are some other locations which are connected using Cisco CSR. And what it is allowing us to simulate the actual environment where you have got the Express Route as well as site-to-site VPN. So now, in order to deploy Azure Route Server, the first thing is the Azure Route Server is actually in preview, which means if you go on a portal and if you have not enabled the feature flag, you won't be able to find this service. Now, in order to access Azure Route Server, you need to first go to this URL, which is aka.ms route server. So once you go to this URL, it's going to launch the Azure route server service. And obviously, you can deploy it using the CLI as well. If you do not want to use it, the Azure portal, that option is available. So since I have deployed the route server, I can see my route server, which I actually named as route server itself. But if you need to create a new route server, you simply create a new route server, give it a name, provide the resource group, and you can use the public IP address. Now here, if I select the region and if I select my network, it looks for this route server subnet. Now, if I try to select a different subnet, I can't use it. So this kind of a requirement that you need to have a route server subnet. That's kind of a prerequisite. Now, once I fill in this information and click next, it's gonna take 20 to 25 minutes to deploy the route server. So since I've already deployed a route server, I'll close it from here and I'll go back to my existing route server. Now, if I click on route server, I can clearly see that it is using the ASN, which is 65515. And that's the reason I can't use this ASN for my on-premises VPN or any other device. And it has got two IP addresses because this is highly redundant service, which gets deployed in two different, availability zones for the high availability. So that's the IP address of my route server, which it has picked up from the subnet, which we selected. So once it's done, the second option, what we need to do is configuration. So I have disabled it, and I'm gonna enable it and gonna show you my demonstration. But just to give you the perspective, as I said, we have got scenario where I have the VPN, and this VPN is basically connected to my VPN gateway, and I have also express route, and this express route is connected. So by default, if I talk about the scenario, my branch location cannot do this transit routing. Means this is not possible if I do not have a route server. By default, what happens is I can only communicate between my VPN sites because they are sharing the same VPN gateway. That communication is possible, but the communications between any branch to the main office is not possible. Communications between branch to my Azure is possible from both express route to Azure or between Azure to express route. But communications between branches is not possible. So this communication is not possible if I do not use the route server. And route server basically provide this capability. Now, so how does it work? It basically just requires this option to be enabled. If I enable it, what it's going to provide me the capability to communicate these between my express route and site-to-site VPN. So I'll enable it in a minute. Before that, I'll show you what's the behavior if I don't enable it. Now, another thing is if I deploy NVAs in my environment, I'll need to configure those NVAs to basically communicate with my route server. So route server doesn't route any traffic. It basically provides the BGP information. So it only helps propagate the BGP information, but the traffic and data path doesn't go through the route server. So this is the most important thing. So if I configure my NVAs, which Nirmal will show in the second part of the demo, what it will do, basically, the route server would help propagate the BGP routes, but traffic is not routing through the route server to the NVA. The traffic will route from a VM to NVA directly. I would just need to supply my NVA name, the NVA's ASN, and NVA's IP address to build that relationship between route server and NVA. So these are the two configurations I need to do when I deploy Azure Route Server. So I'll just go back. The one thing which I also wanted to show in a very quick way. So if we are using hub and spoke architecture, so I'll just go on spoke. And if we talk about peering, we just need to make sure that the spoke has this option enabled. So if spoke doesn't use the remote virtual network gateway or route server, then my spoke cannot communicate and cannot use my gateway server. So this needs to be enabled for my spoke network. So by default, in any hub and spoke architecture, most of the customers enables it in order to communicate between their branch office to Azure. But this is this kind of a requirement. If you do not enable it, my spoke network would not get the routes from my route server. So, so as we talked about, route server provides multiple use cases. Now, one of the use cases which I'm going to cover is about connectivity between my main office, which is connected using Express Route, to my branch office, which is connected using site-to-site VPN. So in my scenario, which I showed you, and I'll just quickly go over it again, I have got one VPN gateway, and this VPN gateway is basically connected to my branch. And I also have got the ER gateway, and this ER gateway is connected to my main office. And as I said, by default, we do not get this transit routing between between branch and main office, because that's not something which is possible in hub and spoke. Um, but we can achieve it using the route server, because what route server is doing, it is basically helping these two gateways to exchange their route. So VPN gateway is exchanging its route to the ER gateway, and ER gateway is exchanging its route to the VPN gateway. That's how a device or a user sitting here in this location can communicate with device or server sitting in the main office. So it basically uncovers some scenario. If you want to communicate between two different branches, one option is you could have your site-to-site VPN connected with these two branches, and that could be your primary connections, and this could be your secondary connection as well. In some scenarios, some customers have multiple branches and they don't have a way to connect all the branches together, whereas they can use Azure Route Server to provide this connectivity. So this is my lab. As I talked about, I have got two branches which are connected with Cisco ASR router. So in my scenario, I'm using the BGP. So these two branches are connected to the VPN gateway using BGP, but you can have the VPN which are non-BGP as well. So you can have, VPN without BGP, and it will still work. And here I have got a VM sitting in a Google Cloud, which is 10.150.0.2. So if I try to communicate between my different sites, so if I connect to any of my location, I would be able to communicate to Azure, because that's the default routing, but I won't be able to communicate it unless until I enable branch to branch connectivity. So I kind of disabled my branch to branch connectivity, and I'll go to one of my branch location, which is using site to site VPN, and I'll try to ping, this IP address. I'll try to ping, this IP address, and I should not be able to communicate with this IP address, because right now the branch to branch connectivity is not established. So I'll just go back. Oops. Okay, interesting. Okay, I can move it now. Okay, so I have my branch location, which is the 10.100.10.4. So if I go here, it is 10.100.10.4. And if I try to connect 10.150.0.2, ideally it should not work. Yep, it doesn't work. And I'll do Control C, and I will try to ping my IP, which is in Azure. So because it's a site-to-site VPN, it's connected 192.168.2.4, which is this IP. So I should be able to ping this because I already have got a site-to-site VPN connectivity established. So if yep, I can do that because that's the default behavior, and I should not be able to communicate between the branches. So what I'll do is I'll just go back and hit enter, and I will wait. And here I'll go back to my route server, go back to my configuration, and I will enable branch to branch and click save. So this takes a couple of minutes to establish. Once it is established, I should be able to communicate from my branch to my main office, which is connected using the Express route. So I'll just leave it here. So what it is trying to do, it's going to, with the help of route server, it will basically establish this connectivity. And this is how my network will flow now. So my network can flow from both the sides. It's going to take a couple of minutes. We kind of tested it. It takes almost 2 to 2.5 minutes time. In the meantime, if you have any questions, feel free to ask. Yep, it's updating. Oh, there you go. So I can ping it. Now I can ping my branch. So from my branch to main office, I can ping it. So this is kind of enabled using the Azure route server. Cool. I think that's what I wanted to show. Now I'll let Nirmal to introduce himself and talk about scenario number 2.
Yep, sounds good. Thank you, Deepak. Let me take over the screen and share my screen. All right. All right. Hello, everyone. This is Nirmal. I'm based here in Perth. I work for Microsoft. So today I'm going to walk you through a couple of scenarios that's enabled using Route Server. So Route Server is a new service that was announced about 2 months back, still in preview. The service is expected to be generally available in a few months. So at the moment, this service is in preview. So Deepak walked us through one scenario, which is around the branch and the express route transit. That is one use case. And I'm going to walk you through a second use case, which is specific for NVAs. So when you look at NVAs or any kind of appliance that you deploy to Azure today, you need to, if the appliance is to be used, or if you want to have traffic sent through the appliance, you need to use a static route. So Deepak at the start talked about using user-defined routing to override the default behavior. So we can send traffic through the NVA. So this is used if you want traffic to go through an NVA for security purposes. So you want to filter traffic, you want to restrict internet access. You can do that through by using a UDR and saying next hop is the NVA for traffic. It's also used when you have traffic going back to a branch or going back to a head office. you want that traffic to be sent through an NVA. That's also possible. You can have in your gateway subnet, you can say traffic destined to these VNets, go through the NVA, and you can navigate and manipulate the traffic to go via a device. So why route server? The reason why route server and the benefit it's going to add is that when you really look at implementing user-defined routing, if you have quite a lot of VNets, and also if you have quite a lot of branches and on-premises, it becomes complicated to manage this static route table, because every time a new branch is added or every time there's a change on premises, you need to go in and update the user-defined route table if you want traffic from that particular branch to go through the NVA. So using route server, we have another capability. Instead of using user-defined routing, we can allow the NVA to inject routes back to our platform. So the NVA can say anything that needs to go to internet, I am the next hop. So you can advertise the next hop as the NVA IP. And then similar to that, any routes that the NVA is learning. So let's say the NVA is having either a point-to-site tunnel or a site-to-site tunnel. Any routes that the NVA is learning can also be injected back to the platform. So rather than you using static routing or using a route table, you can allow the NVA to dynamically go in and implement routing to the platform. So any changes that happens, even a new VNet that is getting added, or any changes that happens at the head office or the branch will be automatically implemented to the platform without needing to go in and make any changes. So what I will do today, I'm going to walk you through an environment that I've created. So this is based on a recent proof of concept we did for a customer. And in this environment, what we are doing is we have an active passive NVA. So one NVA is active, the other one is passive. I've also created a second environment as well, where we have both the NVAs active participating in the route advertisements to the platform. So with that, let me go to my demo environment. So in my demo environment, I have, as I mentioned before, I have two instances. So I have one instance here, which is my active passive environment. So very similar to what you would see in a typical hub-spoke deployment. You have a hub VNet, and then in this VNet, you will have your appliances, all the shared services, express route, VPN gateways, all of that would sit in this hub VNet. And then I have spoke VNets in here. I have the same exact setup replicated in here as well, which is my active setup. So again, same setup, same IPs that I've created. And then the difference is that in here, both the VMs are active. So essentially, it's advertising the routes directly to the platform as an active pair. So the first thing that I want to show is I'll go to the route server and show what is being configured. So if I go to the route server, as Deepak mentioned before, we have the route server with our internal AS, which is 65515. And then the route server is always deployed as a pair. So it provides redundancy by default. So that's why you do have two IPs. There's a .4 and .5. And then if I go to peering, this is where my NVAs are going to connect with the route server. So that's the partnership that the NVAs are forming with the route server to inform about the routes that it's learning from the device. So here you could see I have two peers. So I have a CSR1 and then I have a CSR2. I've got its own ACE number here. So these are the ACE numbers that the routers are using or the NVAs are using. And then these are the two IPs that are allocated to the NVAs. So that's the peering relationships that's been formed by the NVA with the route server. So if I go back, that's my route server config. What I will show is in an active passive setup because the peering relationship is already formed. If I go to effective routes, what it should show me is there will be routes that are now advertised to the platform from the NBA. So it'll show as virtual network gateway, and those routes will be injected into the platform. So if you look in, I have the internet route, which is the 0/0 route advertised by my NBA. So this is an active passive setup. So that's why you're only seeing the 2.11 IP address that's been advertised as the next hop for this peering relationship. We are not seeing the passive route here in the route table. However, if I go back to my dashboard and if I go to my second environment and if I open up the network interface in here, what you would notice is that if I go to effective routes, here we would see the active behavior. So what do I expect to see with the active behavior? I'm going to expect to see the default route or the internet route advertised by two instances. So you could see here we have one instance advertised by 2.12, and also I have the same route advertised by 2.11 as well. So these are now working in an active mode, which means that I could be accessing Microsoft.com from one NVA, and I could be accessing Bing.com or Amazon.com from the other NVA. So it's essentially going to provide me active connectivity based on the request that I'm making to the NVA. So I'm now going to show some of the additional information that we can see in the route server, which is not exposed in the UI at this stage, given the service is still in preview. So let me open up my VS Code environment. And here what I want to show is, I want to show what you'll be seeing once the peering relationship is formed. So first thing I'll show is that I'll show the behavior of the route table and also the behavior of the peering information that we can see within the route server. So here I'm running a command against the route server to show all of the routes that it's learning and also the different peering relationships that it's forming. So here you could see I have the local IP, I have all these different networks that I'm advertising to the platform. And then it's also showing me what is the origin. Is this something I'm learning from a remote source, or is this something that I'm learning from an internal source? So key thing here is that the ACE path information. So you would see here I have ACE path as 65001. But if you look at the second instance, here the ACE path is repeated, which means that I have purposely made this a longer network path, which is how I'm making it active passive. So when I go to a VM and say, give me the effective routes in that particular VM, the VM will only show me the active path. It's not going to show me the passive path unless I do a failover. So when I do a failover, which we will see in a demo shortly, we would go to the NBA and we would disable the network interface, which means that dynamically these routes would be removed. And then the passive instance would automatically go in and take over. So before I do that, I want to show a few things. So in this active passive setup, what I will do is I'm in the hub VM. So let me double check which one I'm on. Yeah, so I'm on my hub VM here. And then I want to first make sure that we have internet connectivity, right? Because we are advertising the default route to this VM. So ideally, if I do go to www.microsoft.com, I should get a response. So I'm getting a response, which means that I now have internet access. But let's verify, how are we accessing the internet? What is the next hop? What is the path to get to the internet? So for that, I'm going to use the trace route. And I'm going to say, show me the trace route when I'm going to Microsoft. What am I expecting here? I'm expecting that the path is going to be through my 2.11 VM. It should go through that NBA because I have advertised my default or the internet path to go through this NBA. So when I go through, I can see in the trace route, this is now going through 2.11. And if I wait for the trace route to complete, it would also show me additional hops that I'm going to have part of this trace route that I'm doing. So this allows me to determine the next hop path when I'm accessing other resources, even if it's a web resource, or even if I'm going back to on-premises. Through traceroute, I can look at the different next hops that I'm going to have. So while I have this here, what I'm going to do is I'm going to do a quick ping. So I'm going to say ping www.microsoft.com. And then while this ping is running, what I'm going to do is I'm going to do a quick failover. So how am I going to do the failover? I'm not going to go to the VM and shut down the VM because that's not a sudden event. Because if I do shut it down, it will automatically remove, knowing that the VM is shutting down. Instead, what I'm going to do is I'm going to SSH into my NBA, and I'm going to disable the network interface. So let me do that. I'm going to run bring down CSR1. So when I run this, what it'll do is it'll SSH into the CSR, and then it's going to shut down the gigabit interface. If you look at here, what it's done is it's issued the shutdown command against the interface, so the interface will be disabled. And if I am looking at my ping, you would notice that I've lost a couple of pings here. So between 39 to 52, I've lost a couple of packets because that failover takes about 20 seconds to work. So if I stop this here, you would notice that there's few packets that I've lost. From a user point of view, they wouldn't really notice a lot because TCP would go retransmit, but you would see a downtime between 20 to 30 seconds when we go and do the cutover. So now that we know the cutover is done, so that the interface is disabled, I'm going to do the same trace route. And here, I'm now expecting to see this trace route go through 2.12 automatically rather than going through 2.11. So you could see here that the next hop path has automatically changed. So I didn't have to go touch any UDRs. I didn't have to run any kind of scripts or anything to go update my UDRs. The platform automatically went in and updated these routes in the environment. So it's the same thing if I go do an show effective route on the VM. In fact, we can have a look at it here on the portal as well. So if I go to my active passive environment and have a look at the effective routes, what you would be seeing here is that you would see that the next hop for the internet path is automatically changed, and that would be sending traffic directly to 2.12 instead of sending that to 2.11. So that's the dynamic nature of the route server, to be able to learn those routes from the NVA and then automatically inject it back to the platform. So if I now bring up my interface, you would notice that it will now, because this is the passive instance that is now running, if I say bring up my CSR VM, this would then bring up the active instance, and then the passive one would take over. So again, we will see around 20 to 30 second lag or dropped packets, and then it'll come back online. So if I do the same ping, we would notice few packet drops, and then the service would come back online. We go back to effective routes. We would now see that the next hop would be automatically changed to 2.11. So the change has already happened. So it's just double checking whether the interface is up. So once the interface is up, we will be able to see. So it took around 35 seconds. So if I now run the same command and ask to show effective routes on the VM, we will now see that the next hop gets changed to 2.11. So that's the active passive scenario. Again, we've been able to simulate a failure. We've killed the interface, and we can see that the routes are automatically changed from 2.11 to 2.12. And then when we bring up the active instance back, it's now taking its place because it's got the shortest stays path, and then informing the platform that I am the new owner for this next hop IP, and then broadcasting that route to the platform. So any VM connected, not just within the hub, even if it's connected through a spoke, it would now receive this as the next hop IP across all the different spokes that's connected. So that's good in an active-passive scenario. Most customers would run NVS active-active because you are essentially paying for the license, you are paying for that capacity. So in active-active, it's very similar. So let me switch to active and show what the active-active looks like. So here again, it's the same thing. We are going to talk to the route server, and we are going to look at what are the different routes that it's learning and the different peering relationship it's having. The key difference here, comparing to the one that we looked at in the active passive environment, in here the ACE path remains the same because I'm not manipulating the NVA to be one or the other. I'm saying both the NVAs are the same and send traffic to both these NVAs. So here you can see I've got 2.11 as next hop for 0/0, which is my internet route. And I've got the same thing here as well, 2.12 as the internet path. So we have the equal ACE path in here, which means that it's equal cost multi-pathing. So it's the same cost to go out to the internet from both endpoints. So if I go back to the VM on my active-active setup, we would be getting two different next hop IPs that we looked at before. And I can simulate this here as well in my command line. So let me open up this instance. Yep. So here we can see we have two 0/0 routes that's advertised again with two different endpoints. And how do we verify that? We can go in and say, show us the next hop for a few websites. So let me do Amazon.com. So that's going from 2.12. Let's do Google.com. That one's going from 2.11. So you could see one request going from one IP, and we are seeing the other request go from the other IP. So if I now do this again, it will still show me 2.11 as the next hop. If I do Amazon.com, it's going to show me 2.12 because it's already established the TCP path to get to these resources. So it's essentially load balancing now between these two NVAs because that's already advertised to the platform. So I'm going to do the same thing here. I'm going to do a ping against Google, which is the first interface. So that's 2.11. And then I'm going to bring down the interface. So let's do a ping request here. So it's exactly the same scenario as we looked at in the active passive setup. I'm going to SSH into my CSR, and I'm going to kill the interface. So here I'm going to bring down the Ethernet interface, and that's going to then bring down the one path. So what happens is, because one path is not available now, when it's reaching google.com, it needs to discover how do I get to google.com. So it's now discovering the next path to get to the internet, which means it has to fail over now to route through 2.12. So that's what we saw here. So you could see we lost a few packets here. So sequence 19 to sequence 33, we lost a few packets. This essentially takes about 20 to 30 seconds, very similar to the previous example. And then this would allow the traffic to fail over from one to the other. So yeah, so it took 36 seconds in this case. So now if I go back to the Azure portal, and then if I go to my dashboard, explore effective routes on the active setup, that would also now show me that the 2.11 path is no longer available. So previously we were able to see two paths going through 2.11 and 2.12. Here we are now only going to see one path. So as expected, we can only see one path because the initial VM that was also advertised in the same internet path is no longer available. So I've killed that, disabled that interface. There's only now one path to go to the internet. So regardless of what I do, so I can do MTR, go to Google, it's still going to go through 2.12. Again, it's the same thing. If I use a different website, go to Amazon.com, it's still going to go through 2.12. That's the only path that's available. So with that, I am now going to bring up this instance. So if I say bring up the interface, what it's going to do is, again, very similar to what we looked at before. It's now going to go into the CSR VM, and then it's now going to enable the interface again. So if I go back here, we can now refresh the portal that would then start learning the default route from the NVA and inject it back to the platform. So here, if I go in and do a refresh, it would show me the two different paths that's available because the NVA is now active and the NVA is now broadcasting routing information back to the Azure platform. Yeah, so as expected here, you could see we can now see both the 0/0 coming from both the 2.11 as well as the 2.12. So that's a quick demo just to show the capability we have with the route server learning routing information from NVAs. So this could be any NVA that supports BGP, and then it allows the information to be written back to the platform automatically without needing to use any type of user-defined routing or any type of custom routing. So with that, I'm going to talk about a third scenario. So this is another scenario where customers can utilize route server and offer a redundant path. So this is express route and a participating SD-WAN NVA, both deployed to the same hub environment. And here, what's happening is that the express route is having a shorter ACE path. So express route is always the preferred path. But in case if express route is not available, or let's say there's some disruption with the network provider and you don't have connectivity, you could then automatically kick in the SD-WAN as the preferred path. So in this case, traffic would no longer route through express route. Instead, the platform will automatically say the next hop is the NVA, and that gets broadcasted to all of these VMs, and the VMs can now talk back to on premises. So these are the some of the common use cases that I covered. So as Deepak mentioned at the start, ExpressRoute and VPN I think is one of the mostly used use cases for this service because at the moment, unless you use virtual WAN, there's no other way to implement transit routing between VPN and ExpressRoute. So it's a good candidate for customers, especially that are running branches or running offices across different regions. So let's say you have one here in Perth, there are other regions in Melbourne, there are other regions in Sydney. You could then leverage the Microsoft backbone to get to your core services in Azure as well as transit back to on-premises. Second use case with NVAs, again, it's ideal when you are especially looking to filter and route your on-premises traffic going to Azure through an NVA. If you are using an NVA that supports BGP, you could, instead of using route tables, you can use the NVA to automatically inject routes to the platform. And the third use case here is a failover scenario where you can failover from ExpressRoute to either our built-in VPN gateway or to an SD-WAN appliance. I've also added a bunch of resources here. They're all hosted on GitHub. Even the lab that I use today, it's hosted on GitHub. So you could go in if you want to create a demo environment. You could go in and have a look. There's also different partners that are published information. So there's an example for Fortinet. There's also examples for Meraki appliances. So we expect to see more resources and more architecture patterns to be available when the service becomes generally available. But these are some of the resources that's available today. And you can go in and have a look if you want to create it as a proof of concept, have a look what it looks like. There's a couple of other blocks that are added here as well into the slides. This is a pattern that got implemented to a customer. So this is essentially using two different regions, and the regions are connected to each other through the NVA. So the NVAs can inject routes from one region to the other region, so they know about each other. And then they can also utilize ExpressRoute or VPN to get back to on-premises as well. So it's a multi-region design. The other use case here is around internet breakout. So I've came across a few customers where they don't have firewall devices in a branch, So all they have is a router, and they want the branch traffic to go via Azure to get to the internet, because in Azure they've already built their landing zone, they already have their NVAs, so they want to really take advantage of the footprint they've already built on the platform. So in this case, what's happening is that the branch is advertising, saying anything to go to the internet. Next hop is the NVA in the Azure platform. So then it will jump onto Azure and then use Azure as the breakout point to go to the internet. I think with that, we'll open up for any questions or feedback. Deepak, have you been seeing any questions in the chat? Let me open it as well. I think there's one around availability zone. So good question, Zach. I think yes, Deepak, you've answered the question. So it is, yes, it's a region-based service. So if you deploy it to Australia East, then the service is available in Australia East. So when we go GA, the service will also support for availability zones. So deploying it to Australia East would mean that the service will natively take advantage of availability zones. Yes, so for route service, there is a cost. The cost will be published when the service goes GA. So there's a hourly fee for the service. So the key thing here is that because the service, as Deepak mentioned at the start, doesn't participate in the data path, there's no additional fee. So you essentially pay for the service to be available, but there's no further fee for data processing or anything like that, because route server does not participate within the data path. So it's only doing the route exchange. So that's the key differentiation between route service as well, the route server as well as virtual WAN, where virtual WAN participates in the data path. Yep, Steven, I think yes, it's a good one to have a look at what the cost is going to be look like. The route service cost is going to be slightly different in terms of the usage, because route service does not have the data processing fees versus the vWAN, but there's going to be key differences around vWAN being able to do things like manage appliances, do things like custom routing, right? Can control the route propagations between VNets. You can have blue VNets in one hub, and you can have red VNets in the same hub, but they cannot see each other. So there's additional functionality on top of it, but yeah. Very quiet audience.
Cool. Thank you. Yeah. If anybody else has any questions, feel free to unmute yourself and ask it. Otherwise,
I think we'll get the slides and the recording shared as well later on. So yeah.
Yep. Feel free to go through it again. Cool. Awesome. All right. So thanks a lot, guys. Thanks for joining the session. Hopefully you found it useful. Thanks a lot, Nirmal, for
No worries.
For presenting this session and sharing a lot of details about Azure Route Server. Cool.
No worries. Yeah. Thank you all for participating as well.
Thank you all.
Yeah,
Thank you.
cheers, everyone.
Thanks, guys.